Hello and welcome. Today we're going to dive into the bubble sort algorithm. Bubble sort is a simple sorting algorithm that repeatedly steps through a list, compares each pair of adjacent items, and swaps them if they are in the wrong order. This pass through the list is repeated until the list is completely sorted. Now if you take a look at the array I have here on the screen, it has the elements 5, 3, 8, 4, 2. Now after bubble sort, it should be sorted from the lowest item to the highest item. So it would be 2, 3, 4, 5, 8. Now let's see how we can do this with bubble sort. So we first compare the first two adjacent items. So in this case 5 and 3. 5 and 3 are compared. Now the lower item should be placed on the left and the largest item should be placed on the right. Now in this case 3 is smaller than 5. As we said before, the small item should be on the left. So we swap these items. So now we have 3 over here, 5 over here. Now we compare the next two items. 5 and 8. Now as you can see, the lower item is 5. 5 is smaller than 8. That means it's already in correct position since 5 is on the left. So we don't have to touch anything or do anything. We leave it as is. We go on to compare the next two elements, 8 and 4. 4 is smaller than 8, therefore we have to swap 4 and 8 so the smaller item is on the left. 4 and 8. Now we compare the last two items, 8 and 2. 2 is smaller than 8, therefore we have to swap so the small item is on the left. Let's do that. 2 and 8. Now as you can see, the list is not yet sorted, however, we can be sure that the last element is correct. This is how bubble sort works. The largest item bubbles all the way up to the top after each iteration. So now we can pretend that the list or array looks like this. It's just these 4 elements here on the left, and 8 is excluded. Now we call this the first pass. So let me just write that down. Now let's do the second pass, or the second iteration of this algorithm. As we said before, we know 8 is in the correct position. Now let's continue and do what we did before. We compare the first two elements, 3 and 5. As you can see, the lower item is on the left, therefore there's no need to swap anything. So now we compare the next two elements, 4 and 5. 4 is less than 5, therefore we have to swap. Now we compare the next two elements, 5 and 2. 2 is less than 5, therefore we have to swap. And now there's no need to compare the last two elements because we know the final element was already sorted in the first pass. So now we can be sure that the second highest element is in the correct position. The 5 has bubbled from the second position to the fourth position. Now we can repeat this step again on the third pass. Now we know 5 and 8 are in the correct position. Compare the first two elements. 3 is less than 4 and 3 is on the left, therefore we do not need to swap. Compare the next two elements, 4 and 2. 2 is less than 4, but it's on the right, therefore we have to swap it so the lesser item is on the left. Now we can be sure that the number 4 is the third largest element and is in the correct position. Now let's do our fourth pass. Now we know these 3 elements are in the correct position, therefore we only have to run this algorithm for these first 2 elements over here. Let's go ahead and do that. Let's compare 3 and 2. 2 is less than 3, so 2 should be swapped with 3, so the lesser item is on the left. Now as you can see, we now have a completely sorted array from low to high, 2, 3, 4, 5, 8. This is bubble sort. Okay, let's see if we can describe this relationship further. I want to create pseudocode for this algorithm. Now we know we have 5 elements from index 0 to index 4. So n, number of elements, is equal to 5. Let's see if we can create pseudocode. How should we do this? Let's first look at exactly how we use this algorithm. So the algorithm had a few passes, several passes, and for each pass we compared the adjacent pairs unless it's already been ticked off. So automatically we know there's 2 for loops. So let's see what the outer for loop is. So for, let's use I to describe the passes, 0. So just on the side here, I'll write I equals 0, I equals 1, I equals 2, and I equals 3. So let's see if we can find out a relationship here. So for I equals 0, and we did 3, so we have 5 elements and we did 3 passes. So we did 5 minus 3, or 5 minus 2, which is equal to 3, sorry. So this is the same as saying n minus 2. So from I equals 0 to n minus 2, so how many passes we had? 2. And then we said there's another for loop. So 4. Now in this case we're using j equals 0. So we're going through the passes. For each pass, let's say this is j equals 0. What exactly are we doing here? So we're comparing from j to the last element. So again to n minus 2. Let's see if I can write that better. N minus 2. Now it's not just n minus 2. If you look closer, this is how many comparisons have we made here? Let's check the comparisons, because that's what we're interested in to find the time complexity later on. So let's count them. So we first compared index 0 and index 1. That's one comparison. 2 comparisons. 3 comparisons. 4 comparisons. So we have 4 comparisons. So this would be j equals 0, 2 minus I. That's because for the second pass, we had 1 comparison, 2 comparisons, 3 comparisons, but not the 4th. So we minused I. For each iteration, we minus I. Does that make sense? So for this one, we had 4. For this one, we had 3, 2, 1. 4 comparisons, 3 comparisons. Here we had 2, and here we only compared 1. Now since we're starting from 0, this would be minus 2. So it would be 0th comparison, first comparison. Let me highlight in red just to make it more clear. So this would be the 0th comparison, the first comparison, the second comparison, the third comparison. Because we're starting from index 0. So we can describe this again using n minus 2 minus I. So 5 minus 2 minus I in this case is 0 actually, is equal to 3. So 1, again, highlight in red. So 0, 1, 2, 3 comparisons. Now let's check for the next one. The next one, when I equals 1, when I over here is equal to 1, we add 5 minus 2, according to this formula here, according to this, 5 minus 2 minus 1 is equal to 2. So again, let's count. 0, 1, 2. We know it's correct. So we have the outer loop for each pass. We go through each element except the ones that have been checked and do. Now we do a comparison using an if statement. If A j plus 1. So what we're doing is we're getting the first element. So we're getting j. If this is j, we're getting j plus 1. This is j plus 1. And we're checking if it's less than j. So if j plus 1 is less than j, what do? We swap them. So this was originally, I'll write it up here. So this was 5, 3, 8, 4, 2. If you recall, that's the first array we started with. What we did, we checked the first two elements, 5 and 3. So this would be j. This would be j plus 1. So if j plus 1, in this case 3, is less than 5, then we swap them. So let's write that. We swap. Let's swap a j plus 1 of j. Now that is a pseudocode. Okay, now let's take a look at time complexity of bubble sorts. So if we move over to the side here, let's see what the time complexity is. We have one for loop here and one for loop here, and both use n. Now from the code, if we do n times n, so n here and n here, n times n is equal to n squared. So we know the time complexity would be O of n squared. Now how can we show this mathematically? So looking at this code, we can create a few summations. So we can find the complexity, or C of n in this case, would be equal to, this is I equals 0 to n minus 2. And then multiplied, because it's for loop in the for loop, j equals 0, n minus 2 minus I. And we put a 1 over here. Now the reason there's a 1 here is because we have this swap operation, and this is a constant time operation. It takes O of 1 time. O of 1 time. That's what we have the 1 there. Now let's see if we can solve this. So this is equal to, we use the summation rules to n minus 2 I equals 0. Then using this rule over here, I'll write it in the top corner for you guys. So summation u I equals L of 1 is equal to u minus L plus 1. So that's how we can solve the first summation over here on the right. So this would be the summation times, so using this formula over here, so the high bound is u, the lower bound is I equals L. In case you can't see that, let me make it more clear. L. Now using that formula, we can get this summation over here that would equal to n minus 2 minus I minus 0 plus 1. This would equal n minus 1 minus I. Now, how do we solve this? Now we can use this formula, sum of the terms of an arithmetic sequence or arithmetic series formula, and solve this. This is equal to, our n is over here, n minus 2. So n minus 2, the first term, which is 0. If we substitute in 0, it would be n minus 1, plus the second term, if we substitute n minus 2, it would be n minus 1, also in the bracket, minus n minus 2. Now let's just expand this real quick. Get the minus 2 up here, divided by 2. So let's add that. And there you have it. So that is our answer. Now we know this is an element of O of n squared. How do we know this? Well, if you expand it, it would turn out to be n squared minus 2n over 2. In bigger notation, you only look at the higher order number, so 2n goes away, and you get rid of the constants, so it would just be n squared. So it's an element of O of n squared. So this is the worst case time complexity, the best case, and the average case. Now we can make an addition or a change to improve the best case. Now what this addition is, I'll copy over our pseudocode. So if we add a variable here, swapped is equal to false. And once we go over here down to where the swap is, we can add a swapped equals true. We use a boolean flag, called swapped. We set this to false, and this tells us if the elements have been swapped or not. So we can repeat this. So we repeat this until swapped is equal to false. Make sense? So with this modification, we have a swap variable, and if there's no swaps that happened during the algorithm in the bubble sort, that means the list is already sorted. Therefore, we exit. With that modification, the best time complexity, the best time would be O of n, since it would iterate through all the elements and stop if no swaps are made. Now let's see if we can implement this using Python. So we'll define the algorithm. So bubble sort that takes an array, and the number of elements is equal to the length of the array. And we'll add our modification. So swapped will equal to false. Now for I in range n minus 1, since Python automatically starts from index 0, we don't need to do minus 2, we just need to do minus 1. Now our inner loop for j in range n minus I minus 1. Then we do our comparison. So if the array j plus 1 is less than array j, then we swap them. So array Pretty straightforward. And then swapped is equal to true if they do end up swapping. Now in our outer loop, we can add the if not swapped and return.